We're going to look at how you record numbers and what type of numbers that we're going to be using. So when you record a number, there are two types of numbers. One is called exact number, and these exact numbers are the numbers that you get by counting objects. So for example, if you are saying something like 4 students, 10 students, that's a number that you get out of counting objects. There are also numbers in definitions, like when you are defining a number or a measurement, those are also called exact. Now, why is it important that we have to know which ones are exact and which ones are not? So you will see that when we start talking about significant figures, it really has to do it has a lot to do with either being exact or being a measured number. So one thing you see here in a definition, we have an example here that says 1 foot equals 12 inches. So in this one example, you see that we're trying to define a unit, 1 foot in inches. But it's really important to remember it has to be within the same unit system. If it's not within the same unit system, then it's not exact. So I cannot say, for example, something like 1 gallon, or let's say like it's one gallon equals 3.78 liters. That would not be exact because the gallons is in the US system and the liters are in metric system. So that's not an exact number. 1 meter equals 100 centimeters. That's an exact number because it's a definition of 1 meter in the same unit system. So now, another type of numbers are what we call measured numbers. These measured numbers are the numbers that you get by using a measuring device. So if you think about a number that you cannot do without measuring device, that's going to be called a measured number. So for example, the time, that's a measure, like if I say 5 minutes, that's a measured number because I need to use a measuring device. If you say something like 10 meters, you need a meter stick to measure that number. So that's a measuring number as well. Now, the numbers that are inequalities that are in different unit systems, so you see these numbers are very, very much very similar to the exact numbers, but the difference is that these are in different unit system. So even when you have equality in different unit system, it's still considered a measured number. So there is one exception you have to remember. This is the only one exception. The 1 inch, so this is 1 inch equals 2.54 centimeters. This is exact. It's the only one that is an exception, and we're going to see how important that is when we start talking about significant figures. Any questions about the difference between exact and measured numbers? No? Okay, very good. So let's keep going. Let's quickly look at these sample questions. Classify each of the following as exact or measured number. So gold melts at 1064 centigrades. What's that number? Is it measured or exact? Very good, measured. The next one, 1 yard equals 3 feet. That's exact, very good. The diameter of a red blood cell is 6 times 10 to the negative 4 centimeters. That's measured. As long as you need a measuring device to get that number, that's going to be measured. There are 6 hats on the shelf. That will be exact, very good. And a can of soda has 355 milliliters of soda. So that will be measured. Very good. So now, let's see the measured numbers and significant figures. That's a very, very important topic. A lot of students have trouble with this topic, but we're going to try to dissect it so you guys can understand it better. So when you start talking about significant digit in a measurement, so the digit in the measurements are called significant figures. Now, remember that when we talk about measurements, we're talking about measured numbers, not exact numbers. We're talking about measured numbers. So we have to look at significant figures, and we know that a measured number consists of a certain digits and an estimate digit. The last digit in the measurements is always estimated. For example, if you have 3.54 centimeters, 4 is always estimated. So I'm going to give you an example or show you why that's the case. So I'm going to draw, suppose this is a ruler, and we have this graduation. So assuming they are equal, so we have 0, 1, 2, 3, 4. Now, if I want to measure the length of this line, what would you say the red line is? And these are in centimeters. So 1.5. Anybody else who says it differently? Yes.
Would you do 1.50 since you don't have exactly?
1.50. Okay, I'm going to write that down. We're going to see. But actually, no, we're going to get to that in a minute. So 1.5, does anybody think it's about 1.6? Yeah, one person here, 1.6. Anybody thinks it's maybe 1.7? How about 1.4? Can we really be exact? Like, can we know like that digit, or are we doing our best to figure out what it is? So what do we know about? What can we be absolutely sure that we have? 1. 1 is there. We know we have 1. As far as the point something, that's an estimate. Nobody can argue. You can argue that it's a 1.6. He can argue that it's 1.5. You can change to, I can say it's a 1.4. You can say it's a 1.7. So that's a matter of your own judgment. So what you will see here, the last digit is always estimated. So we don't know what it is. We're just trying our best to figure out what it is. Why? Because there is not a single graduation that shows us this is what the number is. We are estimating. So when you read a number in the book, you are always looking at that last digit as a suggestion. It's an estimate digit. Nobody knows what it really is. They are doing their best. So it really does not carry that much importance, but it does count in terms of the significant figures. Why is it important? Because it protects the number before it. So if we don't have that number, we will think we don't even have one. But it's really important to always make sure that number is there to protect what we already know. So I will give you another example. If I write 2.350, and somebody else writes, okay, so they'll say, oh, well, that's not really different from 2.35. Technically, these numbers are very different from a measurement perspective.
Because you would round the 3, right, with the 5?
Not really, not because of the rounding or anything, but because of what we just talked about, the last digit being estimated. Okay, so when I look at this number right here, I am saying you can change the 0. You can change 0 to 1, 2, 3, 4, 5. It's still not going to change your number. But now, if you look here, that means you're allowed to change that 5. So I can say, okay, I'm going to now call it 2.37. Do you see how now it's different from the original number? So because that 0 has a role, it protects the 5. It tells me that I do have a graduation that has a 5 there. So you can't just remove it. You might say, okay, it does not mean anything, still the same number, but it really does when you do the measurements, because it does protect the number before it. So, and it's also included in significant figures. So like if I was going to count number of significant figures, the first one would be 4 significant figures. The second one would be 3 significant figures. So as long as the numbers have a different number of significant figures, they are completely different numbers. So now let me go back here. So certain digits, oh actually I'm going to return back here. So now the last digit, the very, very last one, is called estimated digit. So that's the estimated digit. Now all the numbers before it are called certain digits. So the certain digits means that we do know we have that number for sure. We have at least, we know we have at least something that shows we have at least 2.35. But in the second number, we can only be sure up to 2.3. We're not sure about 5. Okay? So that's really important. So whenever you read a number, it's very important to remember the last digit is always estimated. It's a suggestion. All the other digits are always certain. That means we know we got them. Okay? So let's see. Go back and let's look at how you read a looter. So you will, in a couple of weeks, actually maybe 2 weeks, you're going to do a lab that requires you to read the instruments. You're going to look at the different instruments. You're going to look at the beakers. You're going to look at the Ellen flasks. You're going to look at the all kinds of instruments, and you're going to be learning how to read them. And I know some of you might say, okay, I know how to read a looter, but can you write the correct number of significant figures from a looter? So that's what we are going to be looking at here. So when you look at this ruler and you look at the green line, you will see that the line is between 2.7 and 2.8. So when you read the number, you're going to start with what you actually know for sure. So what number do we know we have for sure? So we know we have 2.7, right? 2.7 is there. That's what you always start by writing. Write 2.7 because you know you have that number. After you write the number you know, then you have to estimate another digit to protect what you know. That's the estimated digit. So in this case, we know that we don't have 2.8, but we do have 2.7. So therefore, we can estimate something after. Even if it's a 0, even if it lays just right on the line, you always have to even put that 0 on. So we have 2.7, 0.5. Somebody might say it's 2.7.6. Somebody will say it's 2.77. So you could keep changing that number, but just the last one, which is estimate digit. All right. So let's look at this next one here. So we have the green line. Now we're going to do the same thing. So we're going to start by writing what we actually know, which is going to be 4.5. But it's fairly obvious that it actually falls right on the line, 0.5. But we can't just write 4.5. Because if you leave it as 4.5, what would you be saying? You would be saying, okay, I know I have 4, but I'm not sure about 5, the 0.5. So which means that you are leaving the room for anybody to say, okay, maybe it's just 4.7, which is not. or maybe it's just 4.9, which is not. So that's why you always have to protect it by adding that 0, which is part of the estimate digit. So in this case, you will see that depending on the device you use, it results in different number of significant figures. So when you are looking at the significant figures, it really depends on what you use in your measurement. Let's look at the next one, the graduate cylinders. So you will see how these two graduate cylinders actually give us different significant figures. The first one, we know that the number falls between 32 and 33. But it's slightly higher than 32, but it's less than 33. So we're going to write what we know, 32 point, and then we estimate the digit that we know we think it is. So because we read, when you are estimating here, you actually read the meniscus. You're going to read this meniscus here. So you read the bottom of the line. So we'll say, okay, it's 32.6 or 32.7. Somebody might say it's 32.5. You are all correct. So as long as you don't change 32, the last digit can always change. The same case for the next one here. So we have 8.2. So that's the part of the certain digits. So we know we have 8.2. Then we can estimate the next one, which is, I think to me, actually 8.26 is a little bit lower. So I would say it's 8.28 maybe, or 8.2, even 29. So that would be your three significant figures.
Wait, from the bottom of the line?
You read the bottom of the line like here. That's what you would read. So it could be 8, it could be 7. So we don't know, 8.27, as long as we only change the last digit. Any questions? Okay. So how about this example? Which one do you think is the correct answer? Two? So that means the little dots are 0.1. So they go by 0.1, 0.2, 0.3, and so forth. So it would be 8.1, 8.2, 8.3.
So wouldn't that mean 2 and 3 are right?
2 and 3, yes, you're correct. So 2 and 3 are both right. 1 is impossible. So I know that some of some of you guys might say, okay, but it would round it to that. Yeah, but you don't round. So you just read what it is, no rounding. Okay. Let's look at significant figures in calculations. Now, when we have measurements that are used in calculations, we are going to be looking at how we use significant figures. So, like, for example, if you take 2.07 times 3.18, you get 6.5826. Now we're going to learn how to determine the number of significant figures needed to answer a number, and also we'll look at how the final answer is rounding off. Now you have to remember, the reason I started by teaching you what the exact numbers are not part of the significant figures, the topic we're about to discuss, because exact numbers have what we call an unlimited number of significant figures. They are really exact. So for example, let me give you an example. I could say we have 20 students in the class. Or I can say, okay, It cannot be 20.5 or 20.9. It's 20. It's exact. It's as exact as it gets. So that's why this would say it has an unlimited number of significant figures. You can add as many zeros as you want because it's not going to change the number. There is no estimation involved. So the reason they're called exact is because they don't have that estimated digit at the end. You're not estimating. So if you have 5 books, it's 5 books, no estimation involved. That's why we say, if I give you the number and say, okay, 5 books, how many significant figures are in that number 5? How many? Unlimited. I just said it. It's unlimited. Why? Because there is no estimation. You have exactly 5 books. If we say we have 3 cars, how many significant figures are in there? Like if I say 3 cars, how many sig figs? No. Unlimited. Very good. I just say that, guys. So those exact numbers we talked about, the numbers you get by counting, the numbers you get by definition within the same unit system, they are called exact, and they have unlimited number of significant figures. And I can guarantee you're going to get one of these on exam. I'm going to give you something like a 3 apples or 5 apples. How many sig figs are in there? That should be unlimited. Because you get the number by counting, not by measuring, okay? So, another example here, if I say, okay, 1 meter equals 100 centimeters. Now, you have to remember that when we are counting the number of significant figures, we actually count all the digits normally. But in this number right here, 1 meter, when I ask you how many significant figures are there, I know some of you are going to say 1. And a lot of you are really resisting that right now. I know some of you, even like after the class, if I do this, you will still say 1. But I'm telling you, it's not 1. It's unlimited. Yes. Yes. So all exact numbers have an unlimited number of significant figures. Now, why is this unlimited? Because I can say it's 0.00000. I can add as many zeros as I want. Because I'm defining it, I need to set it as exact as it can be. That's why it's called. That's why it has an unlimited number of significant figures. Same thing here. This will also be unlimited because it's defining it. So now if we look at something different, let's see, 35 side books. How many significant figures are in that number? Unlimited. Very good. So not 2, unlimited, because it's an exact number. So when we talk about significant figures, we're really referring to measured numbers. So before you answer with how many significant figures, ask yourself first, is it exact or is it measured? If it's exact, the number is unlimited. If it's measured, then you count the digits. All right, so let's look at the rules for counting significant figures. So we're going to look at how we count the number of significant figures. Now, I don't think we're going to be able to cover all of this so you understand it. It's going to take some time to really get comfortable with it. So you're going to have to really spend time practicing how you count significant figures. But just as examples, you want to spend time really memorizing these rules. The first rule says, all non-zero numbers in a measured number, important, in a measured number. We're talking about measured numbers here. All non-zero numbers in a measured number are significant. So if you have all the numbers that are non-zero, you count each one of them. They are all significant. both exact digit, the certain digits, and estimate digit. Now, for example, the first one here has 4 significant figures, 38.15 has 4 significant figures, 65 has 2, 122.55 has 5 significant figures. So you just count every single digit. That's rule number 1. Rule number 2, sandwiched zeros. That means the zeros that are between two non-zero numbers are also significant. You count them. So 50.8, that's 3. 2001, that's 4. So you count those zeros. It does not matter whether they have a decimal point or not. And then you have 0.40505. That's 5 significant figures. So you will see that the first 0 in 0.4 does not count. And that leads us to the next rule, which is the leading zeros. So the leading zeros are basically the placeholders. They really don't count. They precede non-zero digits. So if you see a number that starts with 0 point anything, ignore all those zeros and start counting from the first non-zero number. That's when you start counting the significant figures. And the good news is, once you start, everything that follows is significant. So, for example, 0.008, I would have to count starting with 8, the first non-zero number that appears. If a number starts with a point or 0 point something, ignore all those zeros, start from non-zero, that's when you start counting. So, 0.008 has only 1. 0.0156 has 3. And 0.000262 has 3 significant figures. And you can keep adding. Anything that comes after you start counting is going to count. Whether it's 0 or non-zero, it's always going to be included in the number of significant figures. Any questions? So please take time to really memorize these rules. I would like to do index card, put a rule on the front, and then 2 or 3 examples on the back, and just give yourself time to maybe just memorize one or know one rule per day. It would take you maybe a couple of 4 days, and you will know all this by heart, and it's going to be really, really easy. So the next one is going to be called trailing zeros. These trailing zeros are the large whole numbers that have no decimal point, and they just are at the end of the number. Those numbers do not count. They're actually called ambiguous. So for example, 25,000 has only 2 significant figures. So when you see a big number that has a lot of zeros, no decimal point, count the number of significant figures and stop at the last non-zero number. So like in 25,000, I would count 2, 5, and then I stop. Everything that comes after those zeros do not count. 200, that's just 1 significant figure. 1,000, 1 significant figure. 2,000, 1 significant figure, and so forth. So because those are really ambiguous, sometimes people want to make sure that they actually give them a specific number of significant figures, which you can do by making sure that you add the decimal point at the end. So you will see here we have this example of 800. So we have 800 and this has a dot at the end. So placing that dot over there changes everything. So the first one has 1 significant figure, but the second one has 3. Because if you put a dot there, then the zeros are going to count. But you can't put a 0 after that dot, because you're then, so So you're going to say 800, or you could say something like 200 with a dot. If you place a dot right there, that will make it 3 significant figures instead of 1. So the zeros after the decimal point or non-zero numbers are always significant. So when you when you place a decimal point in a number, anything that comes after the decimal point is gonna be significant. So the decimal point really changes a lot. So if you have 4.50000, all those zeros become significant, so they count. All the zeros that appear after a decimal point, an easy way to put it plainly is to just say anything that comes after decimal point is going to always count unless it's a zero. So, but if it's a zero that comes after non-zero number, it's always going to count. So, for example, 0.80, that's 2 significant figures. Any questions? So I really encourage you to take time to review and read these rules, because if you have, how many of you have taken or have studied significant figures before? Pretty much everybody. How many really don't like them? Yeah, honestly, a few people like significant figures because they can look a little confusing. But once you really get these rules, you understand them. That's the beginning of really enjoying significant figures. Now, once you know how to count them, we are now going to look at how you use them in numbers. But before we do, let's look at this sample problem. State the number of significant figures in each of the following measurements. So A, how many? How many? Anyone? Just go ahead and say it.
3.
2. So the trailing zeros don't count. So you can see how important it is to really learn those rules. That's where you need to start. Don't think about jumping to any advanced topics before you actually really memorize those rules very, very well. Number 2, or B.
3.
Will be 4. Very good. So all the zeros count there, because the first zero is classified as a what? We had a special way we called it. Sandwiched. Very good. And the last one? It would be the last zero is the zero that comes after a decimal point, so it would count. Okay.
That doesn't make sense. Because 0 with any at the end that doesn't count. Is it just because there's a 4 in the front?
So in that number, what really makes a difference is the dot, the decimal point. If you remove that decimal point, then it would be just 3 significant figures. The last zero does not count. But if you put the dot in there, that means everything, like I said, everything that comes, the zeros after the decimal point will always be significant.
So why does it not apply to A?
A?
Yeah, there's a 0 at the end of both of those.
Well, yeah, but that zero counts too. The trailing zero don't count. The zero that comes before non-zero number don't count. But in this example here, what we are counting really are just these. That's what counts as 2.
Okay. I thought you were dropping the end 0 because you said it was the trailing 0.
No. So in the first one, we are counting the 3 and the 0. In the second one, we're counting everything because it still counts. Now, what I want you to see is that C. We only have 1 because these zeros are the leading zeros and they don't count. So whenever you, like I said, when you see a number that starts with 0 point something, start counting from the first non-zero number you see, and everything that comes after it, whether it's 0 or not. All right, so how about D?
3.
D is 3. Very good. Let's look at the rules for rounding off. Sometimes you will do the calculations and you are required to either round or round up or round down. So we're going to learn how to use those rules. The first digit to be dropped is if the first digit, when the first digit to be dropped is a 4 or less, the retained value remains the same. So I will give you an example here. When we have, for example, 45.832, we want to round it to 3 significant figures. So before we do round, how many significant figures are in our original number? There are 5, right? So we wanted to retain 3. So we're gonna count the 3. So we have 1, 2, 3. That means we're gonna have to stop there. Everything else has to drop. Now you look at the very first digit that is gonna drop. The next digit that is gonna drop. If it's 4 or less, you just drop it completely. So which means our number becomes 45.8. That's the rule. Second rule is if the number to be dropped is 5 or greater, then you're gonna have to round the number to be retained increases by 1. So it rounds up by 1. Example, we have 2.4884. We want to round it to 2 significant figures. So you can see this is a 5 significant figure number. So to make it a 2 significant figure, that means we're going to have to retain just the 4, 2 and 4, which means that 8 is going to be rounding, it's greater than 5, so we increase 4 by 1 and we write 2.5. So to retain, when you have the large values, the numbers that do not have decimal places. So far what we talked about was if the number to be retained or to be dropped is after a decimal point. So if you have a large number that does not have decimal points, then the number to be dropped is always replaced by 0. So for example, if we have 3,246, which is 4 significant figures, we want to round it to 2 significant figures. In that case, we are going to count 2 significant figures. That's going to be 3 and 2. That's 2 significant figures. Everything that follows has to drop. Because it's the next number is less than 4, that means it has to drop, and we would need to replace it by a 0. So you can't just drop it and not put anything there, because in that case what you will end up getting, end up getting 32 instead of 3,200. So the best way to look at it, I tell students, I guess the easy way to understand it is like if you were getting paid and your boss owes you 2,000, like I said, 2,565. So your boss owes you 2,565, for example, dollars. And he's like, you know what? Let's just round this to 1 significant figure. I'm gonna pay you round it to 1 significant figure. How much would that be? And you're like, okay, so 1 significant figure. You're like, okay, oh well, that's 2. So he gives you just $2. That would not make sense. You're like, okay, so you owe me 2,000 now. I'm getting $2. No. So instead, rounding to 1 significant figures, what would it be? Very good. So you get more money because it becomes 3,000. So you would count, okay, 2,000. That's 1. So everything that comes after has to go or has to change. The next number is 5. So that means you round the number before it by, you increase the number before it by 1, which makes it 3. And then you replace all the numbers by 0. So obviously you can see 3,000 and 2,500 are not that different. They're slightly close. It's not the same as 2,500 and just $2. So that's how you really need to look at it. When you round, you look at the original number and the number you get and ask yourself, are these numbers even close? Because they gotta be close. So if the answer requires more significant figures, then you would have to add the zeros and the decimal points. So for example, if you have 4 and you need to write 3 significant figures, you would put 0.00 because the zeros only change the significant figures and so forth. Alright, so let's look at the rules for calculation in measurements. Now, I am hoping that everybody now is okay with counting. So when you are looking at significant figures, I want you to look at them in steps. Memorize each step separately. So start by learning how to count them. Just counting the significant figures. If you are taking if you're doing the chem steps, the online version, by the way, those of you you will see the paper version on Falcon Online. Those ones are not graded; they're for you to just practice with. But if you want to do extra credit, you would have to go to chemsteps.com and you would have to sign up for an account and you start working on that. So there's a lot of practice for significant figures. And the way that they're organized, the first quiz is all about just counting significant figures. Nothing but counting. And then the next quiz is all about rounding. Nothing but rounding. And then the next one will come about calculations. Yes, you had a question?
Can you go back to the last slide? I'm sorry. I just want to write down and I don't know where in the book it is.
These slides are on Falcon Online though.
Okay.
Yeah, so you can download them anytime you want.
Okay.
Which slide did you want?
Where number 4 is. That one.
Yeah, so I don't think you really need to copy everything because you can look at on Falcon Online, they're already there, and you can just write them later. But all right, so while she's taking her notes, let's then look at when you use these significant figures in calculations. The first thing that I was saying, the first thing you need to know is be sure you can count them. If you can't count them, the rest is just going to be a waste of your time. So start by making sure you can count them. Once you know you can count them, then make sure you can round them. We know when to round up or when to round down. Those 2 rules we talked about. And then, after you know that, then we're going to talk about how you use them in calculations. So, let's look at the calculation is divided in 2 parts. And this is really, really crucial for you guys. Some students fail to recognize that there are different rules for each operation. So we divide the significant figures into 2 groups. The first group we're going to talk about is when you have division or multiplication. So when you have division or multiplication, the answer you get is the same, has the same number of significant figures as the measured number with the fewest number of significant figures. What does that mean? So you're going to look at all the numbers that you're multiplying or you're dividing, and you're going to count the number of significant figures in each number, and you're going to write down how many significant figures are in each number. Then you do your calculation in your calculator, whether you multiply or divide. Then you get the answer. you're going to round the answer to the same number of significant figures as the number that has the fewest. So here's an example. We have, if you look at this this calculation here, so we're multiplying two numbers. The first one has 4, 110.5, that's 4 significant figures. The next one has 2.048, that's 2. So now we multiply in our calculator, this is what we get. After we get our number from the calculator, then we're going to look at the numbers we multiplied. We know one of them had only 2 significant figures. That means the answer should only have 2 significant figures. So now we will round this number to just 2 significant figures, and it becomes 5.3. So you can see how those two things we learned come in handy here. Counting and rounding, because that's what we're doing. So we're doing the count. I know that we all can just do this multiplication and divisions, but it's really important that you can count, you can round, and these significant figures. Let's look at this next example. 7.14 and divided by 11. So 7.14 has 3, 11 has 2. So the answer should have just 2. So therefore, the answer we get, which is 6.4909, rounds to 2 significant figures, which is just 6.5. Now we have the last one here. So we are multiplying 110.5 times 0.0480 divided by 1.1. So now we're going to count the number of significant figures in each one, and we're going to write down with the fewest. So as you can see, 110.5 has 4, 0.0480 has 3, and 1.1 has 2. So the answer must have just 2 significant figures. After you do the calculation in your calculator, you're going to have to round the answer to just 2 significant figures. Any questions? Yes.
Wait, so for the first portion of it, how did you get the 2 significant figures? Like for the 110?
Oh, no, the 110 has 4, right? And 0.080 has 3. And the 1.1 has just 2. So we multiply our calculation, and we look at, in all the numbers that we multiplied or divided, the one that has the fewest number of significant figures, which ends up being 1.1 with 2. And the answer has to match that. It has to be just 2 significant figures. Any other questions? Okay, so let's look at now we're going to look at the second rule. Excuse me. The addition and subtraction. When you are adding and subtracting, the answer has the same number of decimal places as in the measurements with the least number of decimal places. So it's almost like a similar rule, but this time we are not interested in significant figures, the number of significant figures. We're looking at the decimal places. And that's really, really crucial. That's very, very important. A lot of students get confused about this. So you have to remember that when you are adding or subtracting, you don't count the number of significant figures. You only count the number of decimal places. You're not interested in the number of significant figures. Although this is all about significant figures, but we are not looking at significant figures. We're looking at decimal places. So for example, 25.2 plus 1.34. We're going to count the number of decimal places. So the first one has 1 decimal place. Notice that we're not counting the sig figs. If we were counting sig figs, the first one would have how many? 3. But we're not even looking at sig figs. We're looking at decimal places. So the first one has 1 decimal place. The second one has 2. So therefore the answer should have just 1. And we're going to still follow the same rule for rounding. Whether it drops or it changes to, it rounds up. So when we do the calculation in our calculator, we would get 26.54. But we know that we can't report more than one. Let me, just for an example, let me ask a question here. So what if we had this? What if we had 10 point, actually 10 plus 0.4. What will that be? Uh, 10. Somebody says 10, right? Is that right?
No.
10.4, right? Is that what you're saying?
Yeah.
Okay, what rule are you following? Because right now, I want you guys to forget about what makes sense. Rules.
The least decimal place.
Okay, so which one? Okay, so the first one has how many decimal place?
None.
None. The second one has?
One.
So the answer should have?
One.
None.
It's
None.
not a decimal place though.
I know, it's confusing. So you keep the least number of decimal places, which means that if there is a 0 decimal place, that's the least, right?
Yeah.
So the first one has a 0 decimal place. The other one has 1 decimal place. So therefore, the answer should have 0 decimal place. So the answer is technically just 10. And I know that you're like, okay, so you just added something, it just doesn't make sense. You add something and just comes out the same? What kind of math is it? But I think chemistry actually explains it a little bit explains it better. So I'm going to give you an example. Let's say that you have, remember how we talked about reading measurements? Let's say that you have a graduate cylinder. Actually, I'm going to say we have a beaker. And this beaker has 10, 20, 30. So let's say that we have water in here, and this water happens to be exactly 10. Now I have another little tiny graduate cylinder that happens to have 1, 2, 3. This one happens to just have 1 milliliter of water. Now, when you are not looking, somebody comes and they just take this 1 milliliter of water, they pour in there, and you just come back, you look at just this. Will you even know that it's, and they say, okay, write down what it is. Will you know that it's different from 10? No, you won't even tell. So because you are not allowed, you can't really have, it does not move the exact, the estimate digit. So it's still going to be the same. That's why when you add 10.10 plus 0.4, it still comes out to be 10 because you are adding it to an instrument that does not give you any certainty at all. So that's why we end up basically with the same thing. So let's look at the examples. Let's give the correct answer here. Can we do without even calculations? Can you do it without doing any calculation here? I think you can. Yes.
Yeah, it's only going to be 2 significant figures.
So the answer should be, yeah. So the first one has 3 significant figures. The second one has 2 significant figures. So the answer has to have 2. So far, the only options we have that has 2 significant figures is 2. How about this? What should be the answer? Like if you had to answer like in 1 second, what should be the answer? So, so the first one has how many sig figs?
3. No, the answer is 3.
Okay, so the first one has 4. The second one has 1. So the answer should have 1 sig fig. And so there's only one number that has 1 sig fig, which is 16. How about this one? This one is a little bit more interesting. So now the 2.54 has how many sig figs? 3. Very good. 0.0028 has how many? 2. So we have 3, 2. 0.1505 has how many? 3. So, and then we have 0.060, which has how many? So we have 3, 2, 3, 2. So the answer has to have 2. So you can look at the answers. We can eliminate at least 1 right now. So which one can we just go ahead and just remove out of the options? 1. 13.3 cannot be the answer. So we can go ahead and remove that one. So even if you have no time on exam to do the calculations, now you have 50% getting it right. So you remove 1, and now you have 2. So if you do the calculations, you will see that the answer is going to come out as 11. So it's going to be number 2. Any questions? All right, let's do addition. For each the calculations, round the answer to and give the correct number of significant figures. So now I know that it really takes a lot of practice for students to really get comfortable with it. I know if you look at this on exam, I know that the majority of you will start just counting, okay, so how many significant figures are there? 1, 2, 3. No, you'll be starting wrong. You're not looking at significant figures in this case. What are you looking at now? Decimal places. So you have to look at the number, figure out whether there is any, classified as either multiplication division or subtraction addition. So this one is subtraction addition. Now, if it's a subtraction addition, we are looking at the decimal places. So the first one has 2. The second one has 1. The third one has 0. So the answer should have how many decimal places? 0. So the answer is 1. We don't even need to do any calculations here. We just pick 1 because it's the only one that has no decimal place. Very good. So how about this? This is also another one who can do without even touching a calculator. So the first one has 3 decimal places. The second one has 1 decimal place. So the answer should have 1, and therefore it's going to be number 3. All right, very good. So more examples. Let's see. Actually, I think I'm gonna just cover. Still have about 540 minutes, seconds. I mean, 540 seconds. So I'm gonna give you an example of another type of significant figures that we don't discuss here in the notes, but I think it's really, really important. That's what we call mixed calculations. So sometimes you get a number that is both addition, subtraction, multiplication, and so forth. How do you approach it? So if somebody could help us get a calculator somewhere nearby, and then we're going to just try to do it together. So I'm going to try to get numbers, any random number, small, decimal points, large, and I'm going to just write it down. Okay. So I'll start with you. Give me just a number.
25.
10-5?
25.
Oh, 25. Very good. So she says 25. I want to add a number to this 25. Anybody? 16? Let's maybe just do 16.0 to make it, okay? So to this number, I want to divide by a number. Anybody? 9? 9? Okay. So let's multiply this 99 by a number that maybe has a decimal point. 8.2. I like that number. To that number, we're going to maybe add another number. Anyone? Everybody's going to get a chance to give me a number. Just pick a number. Your favorite. 4. 4 point. Let me add something. 0.21. And we're going to subtract that number, hopefully less than 4. Let's say, let's subtract 2.0. So that was my turn. And then we're going to divide this number by something. Any number. 1. 23.4. Very good. So that number we are going to, what should we do to it? Let's add. Add something. It's 19? 14. Very good. Okay. So if you get this, where do you start with all those rules we talked about? How do you do it? This is something that you're going to see on the chem steps, and a lot of you are going to get stuck on there. And that's why many students give up. They're like, I'm done with this stupid chem steps. It's not working. I am done. But it's actually working. It's just this thing that is really hard. Yes?
It would just be in order of operations.
Very good. So you would do order of operations, but now it even makes it simple because we have all those parentheses. So what you need to do is to do each operation at a time. And you don't round, that's really important. You don't round yet, but you do it one at a time. And then you're going to focus on what it actually does. So what we're going to do, I'm going to try to, hopefully it won't be a lot of mess. So I'm going to do this. This is going to be my number 1. This is going to be my number 2. This is going to be my number 3. This is going to be my number 4. And then I am going to add this here as number, actually this is going to come last. And then all of these are going to be my number 5. All of these are going to be my number 6. And that will come as number 7. So basically, I'm going to do it in 7 different operations. And each operation, I'm going to be focusing on specific rules. So let's get started. If you guys can help me with your calculator, if anybody has a calculator somewhere nearby.
The first one comes out to 41.0.
Okay, very good. So the first one is the 41.0. And the bottom one?
811.8.
And I think it should be like, it should be 1. It should be 108, 107, right? Is it 107.2? Oh, yeah, I'm sorry. I'm adding, not. Okay, so you said it's 11?
811.8.
811.8. Very good. Okay, so now we have these two. Now, what do we do with this? So we look at each one, and we're going to follow the same rules. So the first one, we were supposed to be, it's addition. So we count number of decimal places. So the first one has no decimal place. The second one has one decimal place. So the answer should have how many decimal places? None, right? So we are going to underline where it should be. So we're going to underline here. We're going to underline this one. What it tells me is that if I had to report that number as my final answer, it would have been 41, nothing else. 41, okay? So that's why I underline 1 to guide me on my next step. So the next one, the bottom one is we are multiplying. We're looking at the number of significant figures, right? So the first one has 2. The second one has 2. So the answer should have how many significant figures? 2. So I am going to count 1, 2. I underline here. That will remind me, so I'm not rounding yet, but that will remind me what that number should be in terms of counting decimal places or counting significant figures. So in my next operation, if I am counting decimal places, I have to stop where I underlined. If I am counting significant figures, I have to stop where I underlined. Does that make sense? All right, so let's go to the next one really, really quickly. Do you have the numbers for the next one?
2.21 over
2.21 over
37.4.
37.4. Very good. Thank you. So now let's look at the first one. So the first one we are doing also subtraction. So we count number of decimal places. The first one has 2. The second has 1. So the answer should only have 1. So I underline here. Now the next one we are adding, so decimal places again. 14 has no decimal place, so I underline here, no decimal place. 37. Now I'm going to do my next operation. So I'm going to do 41 divided by 811. What would that be the number? So 0.0. So 41 divided by 811.8.
It's 0.05 and it just continues on. Like
Okay, what are those numbers?
it just continues on 0505.
Oh, okay, 0505.
Yeah.
05. So I'm going to write as many as I can. And then I'm going to add, what's that number there? So this is going to be also a
0.059 and then it repeats 09 after that.
All right, very good. Okay, so I'm going to just finish this and then we'll finish later. So, okay, now, so the first number here, we are doing the division. So we count the number for significant figures. As far as I'm counting number of significant figures, remember, I need to stop where I underlined from the previous operation. So the first number, 41.0, looks like it has 3 significant figures, but actually I have to stop by 2, by 1, where I underlined, so that's 41, that's just 2. The bottom one, it's also 2. So therefore, the answer should have 2 significant figures. I underline here. Here. That's 2. Now the next one is also division. I count number of significant figures. 2.21. I stop where I underlined, so that's a 2. And the bottom one, that's a 2. I also stop right here. Now adding, you can see that these numbers now I'm going to add. I'm counting the number of decimal places, but I know I need to stop right here. And for this one, I need to stop here. So the final answer should have just 2 decimal places, which ends up being, it looks like it's going to be 0.1. What's a 0.10, right? So
If you do it on a calculator, it comes up to 0.109.
0.109.
So would you round up in that case?
In this case, you just round it to You round because you want two decimal places. You stop here and you round it to 0.11. So that would be your answer. So sorry guys, I took a little bit long, but I know this is important. We're gonna do another exercise next class. But if you can, just practice a little bit more. Go back to this and see if you can follow the steps, and then we will do another practice next class we meet.